Hello everyone and welcome back to PostNetwork Academy, your go-to place for machine learning, artificial intelligence, computer science, robotics, statistics and probability. In previous videos, I have explained vectors, matrices, tensors in PyTorch, and in this video, I will develop a simple neural network for Iris dataset, and that will make you understand all neat and grit of a neural network, and basically you will understand what a neural network learn. So without further delay, let's get started. So here let us see outline. So first we will see Iris data overview. Thereafter, what is the architecture of neural network? Mathematical formulation, that is essential for any deep neural network. Visualization of IrisNet. Code, we will see that in which how to import libraries and load dataset. How to convert tensors and split the data for testing and training. We will define neural network inside PyTorch, and we will initialize weights also. That is crucial for any neural network. Thereafter, we will understand loss function and how to optimize loss function. Thereafter, we will use training loop and we will see live plot, that when number of epochs are increasing, so how loss function is decreasing or increasing. And we will also see accuracy evaluation. And finally, we will summarize and conclude it. So basically, you can see that we have taken data set from Iris dataset. So in which there are four features: sepal length, sepal width, petal length and petal width. It is from flower, and there are three classes: Setosa flower, versicolor flower and versinica. And if you are in the field of machine learning, you must be aware about this dataset. And for this dataset, I am going to construct a neural network using PyTorch. So here, again what I have explained here, you will see. So we will have four input layers because we have four features. So for a sepal width, petal width and sepal length and petal length, that would be represented by four input neurons. Thereafter, see that 10 fully connected neurons that are hidden layer. So basically we will have three layers. The first one is input layer, hidden layer, and last one is output layer. So hidden layer, there are 10 neurons, and we will use ReLU activation for non-linearity. Otherwise, it would be a linear equation that will separate data points. So we use activation function to introduce non-linearity. Output layer, so there are three neurons for classifying iris, setosa, versicolor and versinica, and that would be final output with softmax. Now training setup, what we have: mean squared error and optimizer stochastic gradient descent, and having learning rate 0.001, and we will use for weight initialization Xavier, that has a property that it has good convergence. Now loss function, we will use mean squared error, and the formula that 1 upon n summation from 1 to n and actual value to predicted value, difference square. Now you can see that yi is the true value and y hat is the predicted value for a sample I. And optimizer we will use stochastic gradient descent, and see that stochastic gradient descent here, that is the learning rate and that is the gradient of loss functions with respect to parameters. And just you will update, this is the update rule for any parameter. And here also loss function you have seen, that is the true value or actual value, that is the predicted value. So I am writing here actual value, actual and predicted. And there is difference, that would be loss function, and because these differences are transformed, because if you use that one, so you will for differentiability and continuity, so you will transform, so square here you have transform. We can also use cross entropy. So transformation is the key in any deep learning or machine learning model. So here optimizer stochastic gradient descent that will use loss function to optimize during back propagation. Thereafter, where n is neta is the learning rate, and you can see that gradient of theta. Now, weight initialization is very important. So we will use Xavier or Glorot uniform distribution. That is the U for uniform distribution, and we will use. Now, here the most important thing, the architecture of neural network. So here we have 4 inputs. So we have taken 4 input neurons, thereafter 10 hidden layer, and that means it will have 10 neurons, 3 output neurons and 2 biases here. See that I want to explain that what will actually a neural network learn. So here we will have 10 into 4 cross matrix weight matrix. See that we will see from the output. So here 10, that is rows and 4 columns. We will have 10 into 4 cross weight matrix, and here we will have 3 cross 10 weight matrix. So basically I will emphasize that this neural network will learn weight matrices, and using weight matrices we can infer a class for an input data set. I will show you so that your understanding would be very clear. Here I have imported library, so torch is very important. First of all, I emphasize on practical things. So code as well as theory. So torch library, that is a core library for a neural network. Using that one, you will get loss function, optimizers, and weight initializers. So here also basically here you will get layers, optimizers in separate library. Iris dataset we will get from scikit-learn library, and we will test and split using that library from model selection, and one hot encoder. So it will just convert label data into numericals. Finally, matplotlib library we will use, and numpy library for some uses like conversion. So here this basically this code import libraries and load data. Now I have divided into 10 parts. Second one, this convert tensors and split data. So here you can say that it will convert into tensor and that it will split into data. dataset for training and testing. Thereafter, here is the important part. A neural network is defined. So here you can see that fully connected neural network with 4 inputs and 10 hidden layers. That means it would be like 4 here, as I have already shown. So 4 and here 10. So you will write 4 into 4 comma 10. 4 input, 10 output. Thereafter one more layer, 10 into 3. So basically here 3 input and 4 inputs and 3 outputs. So 4 inputs and 3 outputs. Thereafter we will also define a feed forward neural network and we will connect. And here we will use a ReLU activation function that will return. Now we will create an object of IrisNet, and thereafter see that again for a weights initialization we will use Xavier uniform distribution of weights with 0 0. So convergence, it will take more time. So there are also algorithms to initialize weights of a neural network and also bias. So bias would be initialized by zeros. So that would be bias, and thereafter we will apply. Now let us see, I have divided code into 10 parts. Loss and optimizers. So we are going to use mean squared error loss and optimizer stochastic gradient descent. That will use mean squared error loss function to optimize the network. And learning rate we will use 0.01. Or we can change, we'll see the code in the code finally. Now live plot, we'll see that how it is being trained, and you will see the live. Now epoch, basically I have reduced it to 500 in the code, and we can so there would means epoch means at one time you are passing whole data set to the neural network. So this is the basically training loop, and we will see that. So what will happen? Finally we will understand how it is working. You will see that how to use softmax in the last layer, and finally we will inspect the weights. That is the most important things in my video. So be careful and just pay attention. So here again I am going to show you the live execution of the program, or I will run it. There okay, you can see that here how loss is decreasing, loss is being decreased, and here loss is being decreasing and accuracy is being increased. So here you can also see the graph, number of epochs. So I have taken 500. Actually previously I took 2000, but I decreased at 500 epochs. So we will see that loss will be decreasing when number of epochs are increasing. See that Why it is happening? Because MSE loss function is a convex function, and that is the property that a convex function has only one minima, or you can say that local minima is global minima. So that nice property makes it, you can say that loss function is decreasing because only one minima. So let us see that, and that is a good thing to watch live training, and it will make your concept clear. See that 400, and I think 460 epochs has run, and it will stop at 499, less than 1. You can see that, and if I just cut it, so you will get, I will get, yeah, you will get weights. So this weight is of 10 cross 4. That means 10 hidden layers and 4 input layers. And this one 3 cross 10. That means 3 output layers and hidden layer. That means you will take rows, you can say that, from output side. So let us see that what has a neural network learned. It has learned, you can say that, weight matrix, and using these weight matrices you can infer. And really what happens in training and inference, a machine learning deep learning model learns weights, and based on that weights you can infer classes. So let us see that here. Again I am explaining that was neural network architecture. So first, fully connected with 10 neurons, activation function ReLU. Second layer, 3 output neurons and 3 probability classes, Satosha, Versicolor and Virginica. Now just I want to classify this input using weight matrices. See here, training it will take time, but for inference just multiply this input to the weight matrices, you will get result. So you will understand that training is very costly, but inference is not as costly as training. So see that here, what I got, that is 10 cross 4 weight matrix, 10 cross 4 weight matrix. And what will we do? We are going to make transpose here. So here we will use ReLU function inside this one. So that matrix is of 10 cross 4 and our input is of 4 cross 1. So basically these are not compatible. So what will we do? WT into X, W2X, that is input. So what will happen? That would be of 4, that would be of 4 cross 1. Basically just wait, that is of 1 cross 4. Input layer is of 1 cross 4. So 1 cross 4 and 10 cross 4, they are not compatible. So if we take transpose, so we will get, that will become, WT will become 4 cross 10. So what will we do? We will multiply 1 cross 4, that is the input matrix or vector. You can multiply vector to matrix. Thereafter 4 cross 10. So simple, you can see that a class senior secondary student can understand. So we will have a 1 cross 10 matrix. 1 cross 10 matrix, that is a vector, and we will pass into ReLU function, and finally what will we get? This vector 1 cross 10. Thereafter we have reached it hidden layer, but we need to reach at output layer. So means data points will reach. So here second one was 3 cross 10, and we have got 1 cross 10 matrix, or 1 cross 10, that if it is 1, so that is, you can say that vector, and this is 3 cross 10. So that means W2, that is. So we will take W2 transpose. So that will become 10 cross 3. So 1 cross 10 and 10 cross 3. So we will have 1 cross 10 into 10 cross 3. And this, after that, we will have 1 cross 3 matrix. That is the output one. So you can see that this is the game of matrix, right? So basically we start from statistics to analyze data set. Thereafter, while training, you use calculus, you take difference, you take derivative of loss function, and finally it learns matrices, that means linear algebra. So 3 subjects you have to prepare. 3 subjects or topics you have to prepare to learn neural network. Otherwise, you might face difficulty. And I will explain you that when you are interested in something, so you can learn anything. So learn it. Even if you have basic matrix, determinants understanding, so learn linear algebra fully. Calculus little bit you can leave, but linear algebra you have to learn. For each step, you will come across linear algebra. Now, at second layer, you will get this one. So that would be of 1 cross 3. And finally, we will use softmax, that will make this value from 0 to 1, because softmax is used for making values of the outputs at 0 to 1. Probabilities, you can say that, proportions probabilities. So here the detailed one, here we have got this output. Finally softmax we have applied. So just what is a softmax, you will keep these values on e to the power, and finally we will sum. So obviously it will come between 0 to 1, and here we will get this value. All are from 0 to 1. So that means here is the highest probability. So we can tell that the class with the highest probability is index 2. So that would be Versinica. So what we have learned? We have performed a forward pass using actual weight matrices. Classification was done by step, and we have used ReLU method, ReLU function, and this process demonstrates how raw features turn into class prediction. So hope you have understood, and you will support my channel, YouTube channel PostNetwork Academy, my Facebook page, LinkedIn page, and you can also find this code on my